I'm Dan Abel, and in this lesson we're going to draw vectors to represent conventional current flow. So normally when we think about current, we think electric circuits, but current is a more general term. Current is the flow rate of any charged particles. Current is a vector. It's got both magnitude and direction. And the direction of current is chosen to be, just by convention, the direction of positive charge flow. Now, there are some things with current specific to a metal like a wire. As you know, metals, like all materials, are made up of atoms, which consist of positive protons in the nucleus and a cloud of negative electrons surrounding the nucleus. And because the protons are pretty much locked inside the nucleus, it's the electrons that are free to flow. They're closer to the edge. And so, as the electrons flow one way through a metal, they leave behind positive charge regions. And so, we can think of electrons flowing one way, or we can just as easily think of positive charges flowing the other way. So, even though it's the electrons that really move, physicists are positive people. And so, by agreement, we think of positive charge flow. And really, the main reason is the electron wasn't known about when that convention was established, but it works. And so there's really been no reason to change it. So just remember, physicists, positive people, everything is defined as what positive charge is doing. A very important thing to mention as well when we're talking about flow direction is that in an electric circuit, current only flows in one direction, either all clockwise or all counterclockwise. So if I have a battery connected to a light bulb, like in this picture, I'm only going to get one direction of flow. I'll never have current flow out of both ends of the battery. And because of the sign convention, I'm always going to flow from the positive side of the battery to the negative side of the battery. Let's try a few problems to drive this home. So for each of the following systems, we are asked to draw a vector to represent the direction of conventional current flow. And so when you see conventional current flow, or really just current flow in general, I want you to think positive charge flow. So we're looking for positive charge flow. So classic example from biology, sodium ions flowing into an axon. So axon, if you're not aware, is part of the neuron and allows us to send electrochemical signals throughout our body. As part of that signal, we have ions flowing in and out of that axon. So since the sodium ions are flowing in, that is the direction of positive charge flow. So the current vector would look like this. I really like this example because so often when we talk about circuits, the direction of conventional current flow is opposite the direction of charge flow. But in this example, we can see a case where the direction of charge flow and the direction of conventional current flow are the same. Let's look at another example. Bulb hooked up to a battery. So again, as mentioned previously, we always move in the direction of positive charge. So by agreement, we have positive charge flow out of the battery, through the filament of the bulb, out the bulb, and back to the negative side of the battery. That's the direction of conventional current flow. And for C, we have an electrochemical cell. And so in order to actually draw this, we would have to know what was in each side of the cell. So let's say that this was the positive terminal and this was the negative terminal. So again, we're looking at the direction of positive charge flow. So our current vectors would look like this at each point. And then in solution, the ions would likewise be flowing in a way that positive ions would be flowing this way. And notice this makes a complete loop, which we know we have to have in order for a circuit type flow. To avoid a point of confusion here, I know sometimes it's easy to look at this and say, well, wait a minute, shouldn't positive things be headed towards that negative terminal? The positive and negative here are related to how the charge is going to flow in the wire. And we'll see a little bit later, this would be when I hook a voltmeter up to this. All the positive and negative tell me is that the side mark positive is at a higher voltage, a higher electric potential than the side mark negative. But we can't have current flowing in two different directions. It has to make a loop that's all clockwise or all counterclockwise. And so if it's flowing left to right in the wire, then the ions, positive ions, must be moving right to left in the solution to form a complete loop. So, key takeaway when you're looking at direction of current, look for the direction of positive charge flow.